All right, welcome back. As we're journeying through logs, I generally, when I think of logs, I think of this right here. I think of, lumberjacks and all those things. Well, we're really not dealing with that kind of log, obviously, as you've hopefully determined by now. I hope some of you aren't sitting around waiting for the discussion to take place about logs and lumberjacks. I hope you have now realized that we're talking about logarithms. And logarithms being our method of solving things like 3 to the x equals 7. And that's how logarithms help us. And I hope you've also realized that logs and exponents are, logs are really types of exponents, or at least they're inverses of exponents anyways. So when we talk about an exponential equation, what we're talking about is a situation like 3 to the x equals 7, where we have an equation with the exponent being a variable. So the exponent is a variable. All right. Let's see if I can make my handwriting a little bit better. I think if I pump up the thickness, it might help a little bit. And obviously a logarithmic equation is an equation that involves logarithms of variables of expression. So anytime you have some variables in an equation with logs, you're that much closer to having a logarithmic equation. So something like, y equals the log of x or something. When we talk about the properties of equality for exponential equations, if b is a positive number other than 1, and if b to the x equals b to the y, that's true only if x equals y. And therefore, if 5 to the x equals 5 to the 4, then x must equal 4. And if x equals 4, then this must be true. If and only if. You get the point there, I hope. You guys like my little tree, little guy swinging here? Huh? Very, very exciting. And he's gone. All my hard work down the drain. All right. Solve 64 to the x and 16 to the x plus 1. Well, when you have something like this, what you're looking for is, do they share the same base? The 16 and 64, are they the same? Well, they're not the same right now, but 64 could be 4 to the 3rd power. Okay? And 16 could be 4 to the 2nd power. All right? So now we have the same base. Therefore, 3 times x must equal, and I got to take that 2 and multiply it times the x and by the 1. So 3 times x equals 2x plus 1. All right? 3x equals, or 2x plus 2, sorry. 3 times x equals 2x plus 2. When I subtract 2x on both sides, I get x equals 2. Is that true? Does 64 to the 2 equal 16 to the 2 plus 1? Does 64 squared equal 16 cubed? Well, let's take a look over here on our calculator. 64 squared, enter. 16 to the 3rd, enter. Yep, it works. And so we've proven this thing to be true. Back to our notes here. Let's clear these out. Let's cruise on down to example 2 and 3. 6 to the x equals 27. Well, how can I do that? What's the way that I can solve that? There's a lot of different ways. Remember, this is what we've really been talking about since the beginning. 6 to the x equals 27. If I take a log of 6 to the x equals 27, and if I take the log of 27 also, you got to take the log of both sides, sorry. And I take that x and I drop it out front. That's usually the way I do this. And so then I have x times the log of 6 equals the log of 27. And then I divide both sides by the log of 6. Log of 6 on both sides. Hopefully you can read that. Log of 6 on both sides. And you'll have a decimal divided by a decimal, and you end up getting an answer. They did it a little different. They said, let's do a change of base formula on that. And so let's do a log base 6. This would mean log base 6 of 27 equals x. So they did the log base 6 of 27 equals x. And then they did a change of base. Log of 27 divided by log of 6. Same thing I did. For whatever reason in my brain, that just works a little better for me. So if I go out and grab my calculator and I get, no, that's not my calculator. I get my calculator and I do the log of 27, enter, divided by the log of 6, enter. I get 1.83 or 1.84 basically. And I could put that right here, 1.84. And I could check that. 6 to the 1.84 would be pretty close to 27 there. Let's take a look at this next example down here. 6 times e to the 0.25x plus 8 equals 20. Well, your first step here would be to subtract 8 from both sides. All right? And then your next step is to divide 6. And you're really just peeling away. So now you have e to the 0.25x equals 2. Well, again, probably what I would do is I would take the natural log of both sides, 0.25x, and the natural log of 2. And it's really the same thing as the change of base, but I don't have to memorize that formula, or at least in my brain, I'm doing things for a reason. I'm going to move this out front so that when I do the log of 2 divided by the log of e, I have 0.25x times the log of 2, or the natural log of 2, divided by the natural log of e. Well, just so you know, the natural log of e is just 1. So I have the natural log of 2 divided by 1, which is some decimal, and I divide it by 0.25. So when I divide both sides by 0.25, I get my answer. So if I grab my calculator and do the log of 2 divided by 0.25, or the natural log of 2 divided by 0.25, and I get 2.08. And I can check that, put it back in the original, and see if it works. 2.08. Excellent. You guys go ahead and do checkpoints 1 through 4. Pause the video. Come back in just a sec with your answers. Pause now. Start now. All right. So as you paused, we have 3 to the 7x minus 3. And hopefully when you did this whole thing, you got a 1. If you didn't, let's talk about it later. When you did this one, hopefully you got a 2.657. And if you're not getting these right answers, go back to those examples and take a look and make sure. Here, you get a 20, and what I'm going to be looking for when I check your notebook tomorrow, I'm going to be looking for somebody who's done some work here, not somebody who's just copying whatever Mr. Emiot has. So I want to see some work on each of these. And a number 4 is a 0. So I'll be searching for that tomorrow. I hope those of you who are listening to the video are actually writing those things down and doing the problems correctly. The properties of equality for logarithmic equations: if b, x, and y are positive numbers such that b does not equal 1, then the log base b of x equals the log base b of y. They are equal if and only if x equals y. And that seems to make sense as long as we don't get too mathematical in our own brain about it. So if I said log base 3 of x equals log base 3 of 8, you would say x must equal 8. And if x equals 8, therefore this would be true. So I hope you guys don't overthink that. I think the book is saying stuff like that just because you might take it to the next level, which I'm afraid we're probably not going to do. Therefore, the log base 7 of this whole thing and the log base 7 of this whole thing just simply says 6x minus 16 equals x minus 1. And those two things are equal, and you solve it. So you subtract x on each side, and you add 16 on each side, and you get 5x equals 15. Therefore, x equals 3. And so the solution is 3. You plug that back in the original to see if that's true. 6 times 3 is 18. 18 minus 16 is 2. 3 minus 1 is 2. Yep, that's going to be true. And so that kind of makes sense. On example 5 is a little different. On example 5, it looks like they got the log base 5, and you got to kind of change this into exponential form. Log base 5 of 3x minus 8. So that really means what I would do is I'd say 5 squared equals 3x minus 8. So I'd say this number here to this exponent equals 3x minus 8. That's kind of like what we did 2 sections ago. And so 25 equals 3x minus 8. 25, see, I think they were going a little different route here. I think I made it a little easier. 5 squared. 25 equals 3x minus 8. If I add 8, I get 33. And 3x equals 33. Therefore, when I divide by 3, x equals 11. And I put that back in the original to see if that's a true statement. 5 to the what is 25. Yep, that checks out. That works. All right. Take a look at another example. A lot of examples in this lesson, isn't there? We got a checkpoint coming up. This has got a lot of stuff to it. This is going to end up having an extraneous solution, or a possible extraneous solution, and we'll talk about why that is in just a moment. When we look at this, you see this plus sign right here? When I have that plus sign, that means things are going to multiply. So 5x is going to be multiplied by x minus 1. So I'm going to simplify that over here. 5x times x minus 1. And I got to do a whoop whoop. Can I get a whoop whoop? And I get a 5x squared minus 5x inside of there. Okay. Now, if I make it into an exponent, if I say log base, now remember, what's that log base right here if they don't say what it is? The log base right there, if they don't say what it is always 10. So log base 10 of this, so what we're going to say is that 5x squared minus 5x equals 10 squared, or 100. And so 10 squared, this 10 to the second power equals this. Now what happens? Well, first thing, I'm going to subtract 100 on both sides, and I'm going to get 5x squared minus 5x. And I hope some of you guys are already got the quadratic formula song going in your brain right now, saying, oh, here it comes. Here it comes. 5 goes in all 3 of these things. Really easy to divide 5 by everything, so that's going to make my quadratic formula look a little easier. X squared minus x minus 20. Here we go. 1, 2, a 1, 2. Oh, let's find our a first. A is 1. B is negative 1. C is negative 20. Here we go. You ready? Everybody ready to sing at home? X equals the opposite of b, plus or minus the square root of b squared minus 4 times ac. A little slow. All over 2 times a. Hoo, hoo, hoo. For those of you non-Catholics out there, I apologize. So I can read my mess. I hope you can read my mess. Negative 1 squared. Remember, parentheses here are super important. Negative 1 squared is 1. 1, negative, negative make a positive. So these two negatives are going to be offset. 1 plus 80 is 81. So I now have 1 plus or minus the square root of 81 all over 2. Square root of 81 is 9. So I now have 1 plus 9. They were going to factor it. That's pretty boring. There's no song for factoring. 1 plus 9 is 10 divided by 2. That's 5. That's one of my possible answers. 1 minus 9 over 2 is negative 8 divided by 2 is negative 4. That's another possible answer. So those are my possible answers. It is important when you get two answers to always check them. Now, it's really easy in my brain to say, you know what, the negative 1 doesn't work. That is not always the case. It may be the case here today, but it's not always the case. So we have the log of 5 times 5 plus the log of 5 minus 1. So the 5 times 5 is 25. And 5 minus 1 is 4. 25 times 4, because of our rule, the log of 100 equals 2. Does 10 to the second power equal 100? Yep, that's true. That one works. Let's try this other one. I have 5 times negative 4, which is going to be a negative 20. I have negative 4 minus 1, which is negative 5. I multiply those things together and I'd get 100, but because you can't find the log of a negative, all right, because those would be undefined right there, undefined, not defined, you have to stop right here. As soon as you find the log of a negative, you stop. You stop where you're at. Stop right here. Stop sign. Look at that. Fancy, fancy stop sign. Stop. Stop right here. Okay? Because you can't take the log of a negative, therefore you're done. You have an extraneous solution. Negative 4, terrible. 5 star on your page. Sound good? You guys go ahead and do those checkpoints. I'll give you the answer. Make sure you show all of your work, and that's how you're going to get your points tomorrow. All right. Let's see. I hope you put some time into it. I hope you got a 6 here with some work. Those of you who don't show work are not going to get points. I've repeated that several times. But I mean, know this, there will be people who aren't listening who just write down answers. So make sure you know, show work. I'll even write it. Watch this. I'll write it, but those who aren't listening won't do it, I bet. Show work. All right. Thanks, folks. Have a good day.